G'day and welcome to this episode on soaps and detergents. I'm going to have a look in this episode at how soaps and detergents and their molecules function in enabling us to remove grease from some dirty dishes. First, let's look at when we pour some oil into water. Now, you may have heard the expression that like dissolves like. What we're talking about there is polar and non-polar substances. You can see very clearly in this instance that the oil and the water do not dissolve. Oil is a non-polar liquid and water is a polar liquid. Oil will dissolve in another non-polar liquid, for example petrol, and water would dissolve in another polar liquid, for example alcohol, but they definitely won't dissolve together. Fine. But if we had grease and oil on a plate left over from food and we wanted to remove that from the plate, and we just put that plate into a sink of water, the oil or grease would not dissolve in the water. So we have to employ detergent to help us to do the job. Now if we put detergent into sink water, the water will be still as colourless and as clear as it would be without the detergent. That's before we wash the dishes. After we wash the dishes, however, we'll see that the water is discoloured. In fact, it takes on a brownish sort of colour. The oil is definitely not floating in a separate layer, it seems to be evenly distributed throughout the liquid. So the detergent must do something to enable this to occur. It makes the water look almost milky. A detergent molecule is a long organic molecule with a very long non-polar tail and a polar head. Now the non-polar tail is soluble in grease and the polar head is soluble in water. An example of this type of molecule is a soap molecule. And you see the very long hydrocarbon chain, which is non-polar, and the COO ion at the end, which is polar. That's a natural surfactant. We also have synthetic surfactants like detergents, which again have a very long non-polar tail and a polar head. So how do they function? If we put our greasy plate into a sink of water and then introduce some detergent molecules, some of the non-polar tails of the detergent molecules will dissolve in the non-polar grease. The polar heads will remain in the polar water. And then with agitation by a cloth or your hand or something like that, you can lift off some of that grease and some more detergent molecules will dissolve in it. Eventually, there'll be a fine droplet of oil suspended in the water. And remember, this is happening all along the plate. So eventually you end up with lots of fine droplets of oil suspended throughout the water. You notice I'm not saying dissolved, there's still separate oil and water, but there is just a suspension of these droplets throughout it. Why do I put the cup of milk there? Well, I don't know if I'm wrong here, but I always or often think of milk as being just fatty sweat. Because essentially that's all it is. It's water and some salts and some fat droplets suspended throughout it. But it tastes good.